Hello everyone, welcome to my channel. Today's topic of discussion would be the modern periodic table, which was discovered by Henry Mosley. We will not be going into detail about it, but we will be discussing few of the elements which will be useful and you will be using it frequently. Alright, let us begin. So the principle behind this modern periodic table is the physical and the chemical properties of elements are the periodic function of their atomic numbers. Means Henry Mosley formed this period in terms of increasing atomic numbers. According to this, he made some vertical groups and horizontal rows. So the horizontal rows which he formed, he termed it as periods, and the vertical groups were termed as vertical columns were termed as groups. So there were 7 periods and 18 groups in the modern periodic table. The groups, vertical groups which were formed, those were representing elements with similar properties, similar physical properties or chemical properties, I would say, and the periods were showing one increase in the atomic number. Means if I am having a element with atomic number 7 over here, the next will be with atomic number 8. Like that he arranged. So as per this arrangement, he divided the entire periodic table into 4 blocks: S block, P block, D block and F block. Left hand side is the S block, right hand side is the P block, middle section we have D block, and at the bottom we have 2 rows consisting F block. So you might be wondering why this F block is being kept separately at the bottom and why not within the periodic table, within the inside of the periodic table. The reason behind this is the elements which are present in the F block, though they were having different atomic numbers, it means I cannot keep the elements in a single block. I have to keep the elements separately, but the physical properties which were there were not that different, which indicates I need to keep them in a single group. So in a single group, but in a different block, was making Henry a bit difficult for the periodic table to be made. So what he did, he converted his periodic table from 2D form to 3D form. I'll tell you how with a simple demonstration. Consider this to be your periodic table. If you just make this periodic table flat, the F block elements lies here, 1 and 2. So here, this way, my F block ka lanthanide and actinide series will be going through the respective position in the periodic table. So my periodic table is not a 2D structure, it is a 3D structure wherein the entire surface is having S, D and P block, wherein my F block, both the rows comes like this, standing. Yeah, so this is the way how my F block, my periodic table has been formed. Let us quickly discuss with the elements present there. So as we know, the very first element of the periodic table is hydrogen, which is now being kept in the center because the properties are it was showing similar properties with that of the S block elements and P block. To keep it simple, S block will be containing all metals and P block will be containing a mixture of elements like metals, non-metals and everything it will be having. Okay, so basically P block has two vertical groups. So one will be alkali metals, second group will be the alkaline earth metals. Wherein my P block, it will be a mixture of metals, non-metals and metalloids, and the metalloids will be forming a zigzag row from which it through which it separates metals and non-metals. The center elements will be D block elements, which will be mostly which will be metals, and the nature of those will be transition metals or transition elements it would be. The elements which are most commonly used we'll start with atomic number. So very first atomic number is of hydrogen, which we already discussed, placed in the center. Second comes helium, which is the P block element ka last group which is again an inert gas, so it is kept at the end of the periodic tables, helium. Then comes number 3 lithium, number 4 beryllium, which is again S block elements. Then again we'll jump to P block. So number 5 comes boron, number 6 comes carbon, number 7 comes nitrogen, number 8 comes oxygen, number 9 comes fluorine, and again number 10 comes neon, which is the last group. Jumping back here again, we'll be going with sodium, then here again it comes magnesium and so on. So these elements are like similar way. It's easy to remember. What is difficult to remember is the periods or the elements which are there in the D block and in the F block. Guys, here I am going to tell you a shortcut to remember the elements present in the D block period, like in the D block of my periodic table. I'll just be telling you the first row of it. Like, this is my way of remembering those elements. I have a shortcut for this which goes like, it starts with the atomic number 21, so which is scandium. So I will do it like abbreviated form में Sakativa Karamanafico Nikuzina. So it sounds like scandium. Like, I will be telling you each and everything. So Sakativa, so it's scandium, tellurium, vanadium. Karamana, so kara is chromium, mana manganese. Karamana. Fico, so it's ferrous and cobalt. Nikuzina, so it's nickel, cobalt, nickel, copper and zinc. Likewise, you can remember the elements which are there in the D block as well. Similar way you can do with F block as well. So if you want me to also give the shortcut for F block or some other elements, you can just mention in the comment section of this video. Also, if you want to give, or if you want me to give the detailed description of periodic table, do mention your feedback. I will be coming up with the next video. Okay, that was all for today. Bye bye. Take care.